Welcome to this lesson where we're going to be talking about right triangle trigonometry. We're going to be applying the trigonometric ratios we've used, but now we're going to apply them to right triangles. And we're going to use them to find unknown sides and unknown angles within right triangles. So as a refresher, here we have our triangle and here's the angle theta. And so angle theta defines where the opposite side is and where the adjacent side is. The hypotenuse is always the hypotenuse no matter which angle we're talking about. But depending on where theta is, that will determine the opposite and the adjacent. So we have our 6 trigonometric ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant is just the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. So the first thing we're going to do is we're going to identify what are these 6 trig ratios for this triangle. So the first thing to do is we have our triangle and we need to figure out what is our hypotenuse. So we use Pythagorean theorem and we say c squared equals 6 squared plus 8 squared. So 6 squared is 36, 8 squared is 64, so c squared is 100, so that means c equals 10. So that is the length of our hypotenuse. Now the important thing to note is that we are using angle B for this triangle. So for sine, sine is opposite over hypotenuse. The side opposite of angle B is 6. So that ratio is 6 over 10, and we'll reduce that to 3/5. For cosine, the adjacent side is 8 over 10, which we will reduce to 4/5. Tangent is opposite, that's 6, over adjacent, that's 8, which will reduce to 3/4. Now once you find the first 3, the second 3 are much easier because you can just take the reciprocal. This is the reciprocal of sine, so this is 5/3. The second one is the reciprocal of cosine, so it's 5/4. And the third one is the reciprocal of tangent, which is 4/3. Let's do another one. So at this one, we again need to find the hypotenuse. So we use Pythagorean theorem. C squared equals 4 squared plus 7 squared. So 4 squared is 16, 7 squared is 49. So c squared is 65. So that means c is the square root of 65. Now we're using angle B again. So that means from our point of view, 4 inches is the opposite side and 7 inches is the adjacent. So for sine, we have 4 over radical 65. Now unfortunately, we can't leave radical 65 in the denominator. So to get rid of that, we multiply. Radical 65 over radical 65. And we get 4 radical 65 over 65. That is our sine ratio. For cosine, it's 7 over radical 65. So again, we have to multiply radical 65 over radical 65. And so we get 7 radical 65 over 65. Tangent is the opposite, that's 4 over 7. Cosecant is the reciprocal of sine. Now what most people do is they make a mistake and they say that we're going to take the reciprocal of this. Better to take the reciprocal of this. This is still sine. It's unsimplified, it still has a radical in the denominator. But what are we doing? We're going to take its reciprocal, which means this radical is now going to be in the numerator, and that's okay. Same thing for secant. Take cosine in this form, Take the reciprocal, and the radical now comes up. So it's radical 65 over 7. And then tangent, that's 7/4. All right. Now what we're going to do is we're going to use the information given to us to help solve this triangle. Solving just means finding all the unknown information. Now, in every right triangle we solve, angle C is going to be the right angle. We know that, and so we don't need to find it. So here we're given angle A and side B. Well, that means we need to find angle B and side A and C. So the easy thing to do first is to say, well, that means angle B has to be 40. So now what? Well, what we can use is we can use the fact that trig ratios compare different side lengths. So tangent of 50 degrees, that's A, is going to equal A over B. Or instead of B, I'm going to put 4. Now the calculator has this number stored. So if I want to find side A, all I need to do is multiply this 4 out of the denominator. So 4 times tangent of 50 degrees equals A. So if I use my calculator, 4 tangent of 50, and we get A to equal 4.77. So now, the only thing left for us to find is side C. But since we know the two sides, the two legs of this right triangle, we can use Pythagorean theorem. C squared equals 4.77 squared plus 4 squared. So 4.77 squared is 22.72 plus 16. We have 38.72. So now we take the square root of that, and we get 6.22 as the length of our hypotenuse. And now we have solved this right triangle. We have found all the unknown information. And in all these right triangle problems, there's always going to be 3 things that are unknown. 3 things will be known. One of them is the right angle. Let's do another one. Here we have the hypotenuse is 7 and angle B is 31. So right off the bat, angle A, that has to equal 59 degrees. So how do we find the other two sides? Well, if I take sine of angle B, that's sine of 31, that has to equal side B, whatever it is, over C, which is 7. So to find the length of side B, all I have to do is multiply this 7 out. So 7 sine 31 degrees equals B. So when I calculate that, 7 sine of 31, we get B equal to 3.61. Now I could use the Pythagorean theorem again, but I find the Pythagorean theorem a little too cumbersome when we have these trig ratios. I believe that these trig ratios are a little bit quicker. If we use cosine of 31 degrees, again, that is angle B, that's going to equal the adjacent side, which is A, over 7. And similar to this, to get A by itself, we multiply 7 over. So 7 cosine of 31 degrees equals A. So 7 cosine of 31, and so A equals 6. Again, I think just a little bit quicker than the Pythagorean theorem when you have your calculator. Let's try a different one. This time we have two sides. A is 60 and C is 100. Well, here we can definitely use the Pythagorean theorem to find the other side. So 60 squared plus B squared equals 100 squared. So that's 3,600 plus b squared equals 10,000. So if we subtract 3,600 over, b squared is going to equal 6,400. And when we take the square root of that, b is going to equal 80. Now the question becomes, well, what can we do now? All we can do is set up trig ratios where we don't know the angle. Well, let's see. Sine of A, what's that going to be? That's going to be side A, which is 60, over 100. But we don't know angle A, so this doesn't help us any. But what we can do is we can say, we're taking sine of A over here. We don't want that. Instead, we want to plug in this ratio and get an angle. Well, what does that? An inverse function does that. So we're going to take arc sine of 60 over 100 and plug that into our calculator. So we're plugging in the ratio, and that is going to give us, the inverse is, it's going to give us the angle, 36.87. That's angle A. So angle B has to be 180 degrees minus the 90-degree angle, that's always there, minus 36.87 degrees. And we get 53.13 degrees. So this is how we handle a right triangle problem where we're given two sides and not an angle. We have to use inverse trig functions to take a ratio and give us an angle. All right, one more of these. Here we have two sides, so we can find the hypotenuse. So a squared plus b squared equals c squared. So we have 4 plus 16 equals c squared. 4 plus 16 is 20. So c equals square root of 20. Now we can leave it in this form because we're just going to use that to find the angles. Now this time I'm going to use tangent. So if we use tangent of A, that's going to equal the opposite, that's A, over the adjacent, that's B. So that's going to equal 2 over 4. But again, we know the ratio, we want the angle. Tangent doesn't do that. Tangent takes the angle and gives us a ratio, so we need the inverse function. So tan inverse of 2 over 4. This is another way of saying arctan. So on your calculator, tan inverse of 2 over 4, and we get 26.57. So then for angle B, we subtract away the 90-degree angle that's there and the angle we just found. And we get 63.43 degrees. All right, so take some time, practice these, come back, and we will see how you did.